Thank you and good morning. Today we welcome Dr. Peter Gleick to this year's Nobel Conference as one of the world's premier experts on water. Dr. Gleick is a MacArthur Fellow, a member of the National Academy of Sciences and the International Water Academy. His research, writing, and civic engagement address the critical connections often overlooked between water and energy, water and human health, the hydrologic impacts of climate change, sustainable water use, and international conflicts over water resources. While all of these credentials are stellar, what many people do not know about Dr. Gleick is that his enthusiasm for the outdoors, nature, and the environment began at an early age and was nurtured by his parents, especially his father. Gleick was actually born in New York City, not generally a place that many of us think of as a pristine natural environment, where youth are able to cultivate a deep admiration, passion, and curiosity for the natural world. As a boy, Dr. Gleick explored and trekked through the rambles in Central Park in New York City with his father to watch birds, and often wandered through the beaches at Nantucket. These excursions ultimately shaped Peter's worldview. Peter's journey to water expert were also deeply influenced by a couple of key summers during his teenage years. At 13 and 14, Peter traveled to remote northern Michigan for science camp, where he conducted field environmental work and began to get a real feel for how science is actually done. Then at age 16, he spent a summer at the University of Southern California doing research on water quality, which, as you can all imagine, set into motion many events that led him to be invited to this year's Nobel Conference. Peter Gleick comes to this Nobel with remarkable and compelling credentials. For over 20 years, Dr. Gleick, president and co-founder of the internationally recognized Pacific Institute in Oakland, California, has worked to find real-world solutions to problems like water shortages, habitat destruction, the human right to water, and environmental injustice, including the problem of billions and billions of people throughout the world without safe, affordable, and reliable water and sanitation. Gleick received a BS from Yale University and an MS and PhD in Energy and Resources from the University of California, Berkeley in 1986. His doctoral research on the likely impacts of climate change on water resources set the stage for Gleick to become an expert on the issues, challenges, and opportunities that surround the world's crises of water. Dr. Gleick is also author of The World's Water, the biennial series on the state of the water, of the world's water, and has published more than 100 journal articles, studies, and book chapters on water. Dr. Gleick is regularly sought out as major source of information on water issues for the media, including CNN, CNBC, Fresh Air with Terry Gross, and has been part of 2 documentaries on water, Running Dry and Flow for the Love of Water. Finally, Dr. Gleick is someone who talks the talk and walks the walk. His family is dialed into the new soft pathway of thinking about the environment. Along with his wife, Nikki, and their 2 sons, they have reduced the family's water use to less than half of the average Californian simply by installing high-efficiency toilets and washing machines in their home and landscaping with native plants to California. I also want you to know that Dr. Gleick is not all work and no play. When he can, one of his favorite things is to get out into the natural world with water as a fly fisherman. Dr. Peter Gleick brings to Nobel an expertise on water that is transdisciplinary in scope and breadth that will serve to probe this Nobel conference and discussion. It is my distinct pleasure to welcome Dr. Gleick to Nobel.
Well, good morning, everyone. President Oli, the Nobel Committee, thank you very much for having me. It's an honor. Michelle, thank you for that very nice introduction. Our water use at home would be even lower if I could get my teenage son to take somewhat shorter showers, but I've not been successful in that regard. Also, congratulations to the college for 45 years of Nobel conferences. It's truly an amazing thing, although I have to say that a college that has a trombone choir is really an amazing place. The title for my talk today is new thinking for the 21st century about water. I think we're desperately in need of new thinking about water. Our current use of water is out of balance, it's unsustainable. We hear about it every day if we listen to the news, and we see evidence from all over the world, from resurgent cholera in Zimbabwe to depleted reservoirs in California or in Atlanta, to farmers fighting with cities over water or fighting with each other over water. I do believe that ultimately we're going to move to a sustainable use of water, to a soft path for water. I think that's the good news. But there are many routes to a sustainable path for water. And the question I think that faces us is how much pain we're going to experience on the way there. I think some paths are easy and some of them are going to be more difficult. Now, before I begin, I'm actually only going to show one slide. This is it. The fact that we call this planet Earth is simply the result of the fact that we are land-based animals. If we actually lived in the water, we would call this planet water because it's mostly water. It's covered with water. But very little of the world's water is fresh water. The big circle on this graphic is all of the world's water if it were in a single ball. The tiny little blue circle is all of the fresh water on the planet. And in fact, of the small fraction of the world's water that's fresh water, most of that is not accessible to us. It's badly distributed around the planet. Much of it is in ice in Greenland and Antarctica. It's in deep groundwater. It's hard to get to. So we live on a water planet. There's a lot of water, but there's not much fresh water, and there's not much available to humans to use. And that's part of the problem, the distribution of these resources. Today, I'd like to do three things. First of all, I'd like to explain why I believe there's a water crisis. I'll also explicitly touch on the issue of water conflicts, but I'll also talk about Sumerian myths and Babylon, Dennis the Menace, snowfall on Mars, Julius and Cleopatra, peak oil, Milwaukee, and Dante's Inferno, all of which you know are closely connected to this issue of fresh water. Second, I'd like to explain why I think the water crisis is getting worse and not better. Indeed, why I believe we've passed the point of something I call peak water, and especially peak ecological water. But third, I'd like to offer some thoughts about why I don't think the water crisis has to get worse, why I think it can get better, and indeed, why I think inevitably it's going to get better. I actually am optimistic about the future of water if we do the things that we're starting to do more aggressively, more carefully, and in a more widespread fashion. I think it's inevitable that we'll move to a soft path, a sustainable use of the world's water. Water issues are not just scientific. They're not just matters of policy or economics. They're all of these things. They're technology, they're culture, they're religion. And depending on whether you're an optimist or a pessimist, the opportunities and the challenges are enormous. Old problems continue to vex us, and new problems are arising. And I'd like to argue that the old way of thinking about water is inadequate. Water is not just a natural resource. It's not just a factor of production. It's not just an input to some economic system. Water is special. People care very deeply about water. And in order to address water challenges, we're going to need new tools, new scientific tools, new technological tools, new ways of thinking about economics, new institutions, new educational approaches. And we're going to have to challenge conventional thinking and the status quo. We've made enormous progress in tackling water problems. Anybody who tells you that all of the news is bad is a pessimist. There is plenty of bad news, but in order to move along a different path, we have to tackle some old taboos, some things that those of us in the water world are sometimes reluctant to think about, and that may be the hardest thing of all. So first of all, why do I think there's a water crisis? Well, there are many pieces to this. There is water scarcity. This little blue dot is badly distributed in space and time. We don't get water when we want it. We don't get water where we want it. There are wet areas on the planet. There are dry areas on the planet. There is water scarcity, by which I mean at times there is not enough water to do what we want to do in all of the places on the planet. There's water contamination from industrial wastes and human wastes. There are water-related diseases, from diarrheal diseases to malaria to schistosomiasis, a whole series of diseases associated with unsafe water. Global climate change is a real problem, as you've already heard. And global climate change will affect our water resources in many different ways. There are challenges to the production of food and goods and services, all of which require water. There's ecosystem degradation and destruction as humans take water that ecosystems need as well. And there are all of the social and political challenges associated with finding and using a scarce resource, from depletion to pollution to inequitable use to water that crosses political boundaries that we do not adequately manage. To me, the worst piece of the water problem, the problem that is truly worthy of the name crisis, in my opinion, is our failure to meet basic human needs for water. There are still 1 billion people worldwide that lack adequate, safe, affordable drinking water, something everyone here takes for granted. There are 2.5 billion people that lack adequate sanitation services, again, something that all of us take completely for granted. Think about it. At any time of the day, we're rarely more than a few feet from safe water or adequate sanitation. And yet, if you think about this, 2.5 billion people without access to adequate sanitation, 2.5 billion people is more people than were on the planet entirely in the 1940s, not that long ago. And the failure to meet basic human needs for water, the failure to provide safe water and sanitation, leads to water-related diseases, to cholera, dysentery, guinea worm, schistosomiasis, and probably 2 or 3 million deaths a year, mostly of small children, and completely preventable. We know how to provide safe water and sanitation for everyone. We have just failed as a global community to do it. And that's inexcusable. There are perhaps 100 million people in India and Bangladesh and Nepal and other parts of the world drinking water with too much arsenic, naturally occurring arsenic. And just as bad, we've known for decades that there's too much arsenic in certain waters, and we have failed to solve that problem, and that's also inexcusable. And so there are a whole series of human dimensions to the global water crisis that we have failed in the 20th century to adequately address. There's an environmental dimension to the water crisis. For too long, humans have taken the water that we need from ecosystems that also need that water. And as a result, many of those ecosystems that provide us with crucial environmental goods and services are all suffering. The most threatened and endangered species on the planet and the most threatened and endangered ecosystems on the planet are those that need the water that we humans use for growing food or for our industrial use or for our residential use. Fisheries, river deltas, wetlands, migratory routes are all threatened by the way we use water. 30 to 40% of all freshwater fish and amphibians in North America are considered threatened or endangered. And this is true in much of the rest of the world as well. The Colorado River no longer reaches its delta in an average year. The Yellow River in China no longer reaches its delta for many parts of the year because we take all of the water that those rivers provide. Others are so heavily contaminated that their natural ecosystems have been destroyed. It's hard to think of a major river system or a major wetland or a major freshwater ecosystem that doesn't face some kind of ecological harm or danger from our use of water. One of the earliest examples of this in the United States was the Everglades, and now we're talking about spending $8 billion or $9 billion or $10 billion to try and restore some semblance of natural flows to the Everglades. These systems have value to us, but we have not adequately addressed that value, adequately thought about that value when we've developed our water systems. Another piece of this environmental puzzle is water quality. Water quality is deteriorating in many places, from biological contaminants, from industrial contaminants, in mixes we don't often expect, with consequences we don't always understand. More than 30 years ago, some of you may remember the Cuyahoga River caught fire and burned on national television, contaminated with industrial wastes. I remember this. This was this was in the days when we used to watch network television. I think there were only 3 channels. We all watched the Cuyahoga River burning, and it was an astounding thing to us. The firemen standing on the banks, not knowing what to do, and that led to fundamental changes in this nation's water quality laws. It led to the Clean Water Act, it led to the Safe Drinking Water Act. 15 years later, Milwaukee was hit by an outbreak of cryptosporidium, and 400,000 people became ill, and 100 people died because we were not adequately regulating for cryptosporidium, and that led to changes in our drinking water laws again. 10 years ago, we discovered the insidiousness of something called MTBE, which we put into our gasoline to make our gasoline burn more cleanly, but MTBE turned out to be a terrible water pollutant, and we were trading an air quality problem for what became a serious groundwater contamination problem, and that led to changes in the mix of our gasoline again. 5 years ago, we found traces of human medicines and endocrine disruptors, some of which you've already heard about, antibiotics in aquatic ecosystems and our drinking water. 3 years ago, we realized the scale of a problem with perchlorate in many groundwater basins in the western United States. Next year, it'll be something else. Our water quality monitoring and measurement and enforcement seems to be one step behind our ability to contaminate our water resources, and that's a problem. And the rest of the world many parts of the rest of the world are farther behind in addressing water quality than we are. In the most disturbing example of our ability to disrupt our environment, we're changing the climate. The evidence is clear and compelling, as you've heard, that climate change not only will occur, but is occurring. And the hydrologic cycle that you all learned about in 2nd grade, evaporation and the formation of clouds and condensation and precipitation and runoff back to the oceans and evaporation again, the hydrologic cycle is the climate cycle. As the climate changes, we will fundamentally alter our water resources. Higher temperatures means more evaporation. Crops will demand more water. Changes in precipitation patterns, changes in storm frequency and intensity. We're already seeing changes in snowfall and snowmelt in high mountainous regions, in the Rocky Mountains, in the Sierra Nevadas, in the Himalayas. We're going to see significant impacts on water resources from climate change. And we're just beginning at the management level to think about how to integrate that into our planning. Even slight changes in water availability, slight changes in the balance between a little more rain or a little less rain is going to alter whether we have enough water or whether there's going to be a water shortage in places around the world. And furthermore, we've built an enormously complex set of infrastructure, dams and aqueducts and wastewater treatment plants and irrigation systems, that assume fundamentally that the future climate's going to look like the past climate. We built our flood control systems. We built our levees in New Orleans on the assumption that the past pattern of the climate's going to be repeated. And if there's anything that the climate community is telling us, it's that that assumption is no longer valid. And there's a third dimension to the water crisis, and that's the political one. It's difficult to think about water, to talk about water, or to work in the water world without thinking about politics. And there are many pieces to this. Half of the land area of the planet is in what's called an international river basin. Rain falls, it runs off in a river. Half of the watersheds, half of the land area of the planet is in an international river basin. We don't think about that too much here in the United States. We have very few international neighbors, but even here, we have international rivers that we often, and international water basins, that we don't often adequately manage. And water has been a source of conflict for millennia. Water is also a source of cooperation. There are many treaties over water. There are many examples of countries and communities cooperating over water resources. And I've worked in the Middle East, I've worked in Central Asia, I've worked in Latin America on watershed cooperation and developing mechanisms for coming to agreement over shared river basins. But there is a long history of conflict over water, from ancient Mesopotamia 5,000 years ago to the modern times. Battles between the Colorado River states, the US and Mexico, between cities and farms. Recently, we've seen tensions between Georgia, Alabama, and Florida over water. Not violent conflict, but political conflict. And in many parts of the world, that political conflict does move over into violent conflict as well. There are regular and growing reports of violence over water in Africa, India, China, and elsewhere. And interestingly, less frequently between nations now than within nations, between ethnic groups, between allocations of water from one user to another. And that's a source of growing concern. Water is a source of conflict, it's a tool of conflict, it's a target of conflicts that start for other reasons. One of the things we do at the Pacific Institute is we maintain a chronology of water-related conflicts. If you're interested in history, I suggest you take a look at it. There are hundreds of examples going back really 5,000 years in myths and legends and actual history. And let me just give you a flavor for some of them. In 3000 BC, there's an ancient Sumerian legend that recounts the deeds of the Sumerian god Ea, who punished humanity for its sins by inflicting Earth with a 6-day storm, very much like the story of Noah. In 1700 BC, a grandson of the great king Hammurabi in Mesopotamia dammed the Tigris in a conflict over Babylon. In 49 BC, Julius Caesar took refuge with Cleopatra, yes, the real Julius Caesar and the real Cleopatra, on the island of Pharos in the harbor of Alexandria, and during a siege against him by Ptolemy of Egypt, they pumped salt water into the palace's water system in order to drive out Julius Caesar and Cleopatra. Water was used as a weapon. In 2007, in August, in Burkina Faso and in Ghana and in Cote d'Ivoire, declining rainfall led to violence between animal herders and farmers who had competing needs for water. In 2008, the Taliban threatened to blow up Warsak Dam, the main source of water for Peshawar. And just a few weeks ago, North Korea released floodwaters without warning into South Korea across the border, killing 8 people. There's another political dimension to water, and that is the fundamental disconnect between our water laws and our water rights system. Water rights are very political, certainly in the Western United States and other parts of the world, and yet most of those water rights systems were developed and arranged and set up 100 years ago or more than 100 years ago. And they reflect the reality of the 19th century or the 20th century, and not the reality, I would argue, of the 21st century. Why do I believe the water crisis is getting worse and not better? Well, many reasons. Foremost among them, population is growing. And it's growing fastest, ironically, in places where our water problems seem to be the most severe. I have no idea why people want to move to hot, dry places, although, you know what? Maybe you understand why people want to move to hot, dry places. But they do. And the southwest of the US has been growing extraordinarily rapidly. Northern Africa is growing rapidly. The Middle East has rapid population growth. There is no problem on the planet, I would argue, that is more easily solved with a big population than with a smaller population or with a slowly growing population. And even in places that we used to think water was abundant, in places like the southeastern United States, around Atlanta, growing population and the style of that population and the level of consumption of some of that population is increasingly worsening water problems in parts of the planet. It's getting worse because of disagreement and paralysis over how to deal with the problem. It's getting worse, I would argue, because efforts and programs to deal with water problems are not adequate to the scale of those problems. It's getting worse because we've delayed dealing with climate change for so long that now we're unavoidably committed to climate change. I think we desperately need to figure out how to mitigate greenhouse gases, to reduce the rate of climate change. But no matter what happens in Copenhagen in December, we're committed to climate change, and that means we're committed to seeing changes to our water resources. It's getting worse because we're mired in old thinking and in entrenched interests and a lack often of political inspiration and leadership. And it's getting worse, I would argue, because we've reached, to some degree, the era of peak water. And let me digress here for a moment and describe what I mean by peak water. Many of you may have heard of the debate about peak oil, about whether or not we're going to reach a point when the production of oil starts inevitably to decline, a point I would note we reached in the United States 30 years ago. But there's a concept of peak water that a colleague of mine and I have written about. Water is a little different than oil. Water is a renewable resource, mostly. Oil is a non-renewable resource, mostly, entirely. And let me define these things for you. The way we think about a non-renewable resource is that it's what we call stock limited. There's a certain amount of something, oil, and when you use it up, it's gone. It's limited. The amount of oil we can use is limited by the stock on the planet, and of course economics and our ability to get it out with technology. But there's a limited amount, and that's the classic definition of a non-renewable resource. Renewable resources are flow limited. You don't use them up. The amount of sunlight that hits the planet isn't affected tomorrow by the amount we use today. The amount of water in a river that's flowing is not affected next year by the amount we use this year. It's affected by the hydrologic cycle, and it's variable, it goes up and it's down, but it's a renewable resource. But it's flow limited. You can use no more water in the river than nature actually provides, and so there's a physical limit to how much water you can use, even of a renewable resource. Water, interestingly enough, also has non-renewable characteristics. There are certain groundwater aquifers, for example, that are non-renewable. They're very much like oil. They're not recharged at a rate of any interest to us. They're recharged over thousands of years or tens of thousands of years. They are what we call fossil aquifers. It turns out that a very substantial amount of the food production on the planet and our industrial water use comes from non-renewable water. And we are reaching the point, and I would argue have passed the point, of peak water in that sense in many groundwater basins, in the Ogallala Aquifer in parts of California, in northern China, in parts of India, with groundwater basins that are not going to be recharged in our lifetimes. But there's another concept with peak water that we call peak ecological water. And that's the idea that as you use water, as humans use water, we get benefit from it. We grow food, we make industrial products. The next gallon of water brings you more economic benefit. And the next gallon after that brings you more economic benefit. But every gallon we use also brings, to some degree, ecological cost. Now, I'll be the first to admit we're not very good at quantifying the ecological value of our water use. But I'd like to argue there comes a point in any river basin, in any watershed, where the next gallon of water use may cause more ecological harm than it provides economic benefit. And that's the idea of peak ecological water. And it's hard to measure, but it's a real thing. And I would argue that part of our challenge is in many water basins, we're already well past the point of peak ecological water. The Aral Sea, for example, where all 24 species of fish endemic only to the Aral Sea are now extinct, is a basin long past the point of peak ecological water. But I said the news isn't all bad, and it isn't. And so for the rest of my talk, I'd like to talk about a positive vision for the future. Let me offer some observations that suggest that a path to a sustainable water future is possible, and in fact, I think inevitable, what I call the soft path for water. And let me describe the steps along the way to that future. But before I do, I don't know how many of you have read Dante's Inferno in the last week or two. And for those of you who haven't, let me just remind you a little bit about Dante's Inferno. Written 700 years ago, approximately, Dante wrote a description of the underworld. It was an allegory of the time. It was a description of local politics, frankly, in many ways. It was a current events story as well. But he described the underworld and his journey through the underworld, his legendary journey. And the underworld has 9 levels, and the devil is all the way at the bottom. And as he descends through hell, each of the levels gets worse and worse, and the sinners in each of the levels have committed worse and worse sins as he goes further and further down. And up at the top are the virtuous pagans and the unbaptized, and I mean, he's got all sorts of people up there. And all the way at the bottom, it gets worse and worse. It's actually a great, you should read it if you haven't read it recently. But pretty far down, in Circle 8, Level 4, to be precise, are forecasters, fortune tellers. Okay, you see where I'm going. And all of the sinners in the Inferno are condemned, depending on their special sins, they're given certain punishments special to their sins. And so the fortune tellers are condemned to go through eternity with their heads on backwards. So they can't see where they're going, they can only see where they've been. Now today, people who think about water scenarios would be there, and maybe climate modelers, and I'm sure economic forecasters would be there. So with that caveat, actually the only good news is that further down are certain lawyers and politicians, and I'm sure cable TV newscasters. Okay, sorry. The water crisis is not the result of a lack of water, or a lack of money, or a lack of brains, in my opinion. Absolute water scarcity is not a problem. There are regional problems with water scarcity, although I would argue there's probably no place on the planet that does not have enough water to meet basic human needs for drinking and sanitation and cooking and cleaning. There are regional problems, there are problems with timing of water availability, but we know how to produce clean, safe water for the world's population. We're a rich world, rich in money and education and ingenuity and goodwill. Now, like water, those things are not evenly distributed, and the uneven distribution of those resources is part of our challenge in this new world. Like water, we have to figure out how to distribute those riches more equitably. But even today, in the midst of a terrible financial crisis globally, the lack of money is not the problem in the water world. Solving our water problems is not solving our water problems is not the result of a lack of money. Too many negatives in that, my apologies. We're intelligent. This isn't a problem of understanding. It's not a problem of the lack of technology. We've decoded the human genome. We manipulate substances at the subatomic level. We've eliminated some diseases permanently and are on the verge of eliminating more. We've developed smart machines that are roaming around now on other planets, ironically enough, looking for water. And interestingly, just in the last few weeks, detecting ice on the moon. So the lack of intelligence isn't our problem either. So let's apply our money, let's apply our brains, let's apply our education, let's apply our water in the most effective ways possible. And so let me talk about 6 issues on this soft path for water. We need to build new water infrastructure in some places, in some forms. We've spent a lot of money in the United States and in the richer countries of the world building dams and aqueducts and pipelines and centralized waste treatment systems to deal with our water problems. And though that infrastructure has brought us enormous benefits, and there are parts of the world where similar infrastructure is desperately needed. Let's build it. I would argue, however, that we need to build it to different standards than we built it in the 20th century. We can no longer ignore ecosystems. We can no longer ignore the impacts of these infrastructure developments on local populations. Big reservoirs that displace 1 million people from behind them. We can no longer build infrastructure in the way we used to. So let's build infrastructure, but let's do it properly. There are other infrastructure investments that are critical. Even in the United States, where we've built a lot of infrastructure, we're not adequately maintaining that infrastructure. We have a great tap water system in the United States, but it could be better, and it could be better maintained. And that requires investment. I think we also need to expand the definition of water supply. This is the second point. The 20th century was a century of supply. We focused on building a new dam, tapping the next most distant river, drilling another groundwater well into an aquifer that was overtapped already. That was what we thought about, inexorably expanding our supply. There are limits to supply, and we're reaching those limits, and those limits are increasingly obvious. At the same time, I'd like to argue that there are new ways of thinking about supply. Let's think about treated wastewater not as a liability, but an asset. We produce a lot of wastewater. We love our toilets, but ironically, our toilets are a remarkably great technology for contaminating a lot of water very quickly. And then we spend a lot of money collecting that water, we treat it often to a very high standard, and then we throw it away. Let's think about it as an asset, not a liability. Let's use highly treated wastewater for power plant cooling, for watering golf courses, for flushing toilets in homes that have dual piping systems, for other industrial uses. There are a lot of things that we can use highly treated wastewater, including, frankly, potable reuse, if we treat it to a high enough standard, which we're capable of doing. That's a new way of thinking about supply. Let's think about rainwater harvesting where it's appropriate. Let's think about desalination. The big circle up there, the big blue dot, is salt water. We know how to take salt out of water. It's very, very expensive, but we know how to do it. Let's think about that in certain places at certain times where it's appropriate. Let's think about what we call conjunctive use of water, that is the combined management of groundwater and surface water. So we may overpump groundwater aquifers at some times, but let's recharge them in wet years. Let's think about them as a reservoir and as a new source of supply. And that's going to be necessary in this new century. Third, I think we need to rethink demand for water. For all too long, water management and policy has been about supply. We have assumed that the demand for water was just something that we had to meet, and we would build more supply to meet it, whatever that demand was. For all too long, the assumption was, as population grows exponentially, and as our economy grows exponentially, usually, the demand for water would grow exponentially. And for a long time, that was true. It's no longer true. and it shouldn't be assumed to be true. The United States today uses less water for everything, for growing food, for cooling power plants, for our industrial and commercial and residential use, for everything, than we used in 1980, almost 30 years ago. Let me say that again. The United States uses less water for everything than we used 30 years ago. People don't understand this. People don't know this. This is a surprise. Even in the water community, this is a surprise. We've broken the link between exponentially growing population and exponentially growing economies and the assumption that we have to have exponentially growing demand for water. We're becoming more efficient at doing the things we want to do. The city of Los Angeles this summer announced that their level of water use was lower than it's been in 35 years. We're doing the things we want to do more efficiently. And this is a key point. Think about it for a minute. We don't want to use water. We want goods and services. We want to grow food. We want clean clothes. We want to get rid of our wastes. We want to make semiconductors. We want to do things. And almost all of the things we want to do require water. But I'm going to argue that almost all of the things that we want to do require less water than we're currently spending to do them. And the ability to become more efficient, to reduce our demand without reducing our quality of life, that ability is going to be a key to the soft path for water. And actually, let me give you a couple of examples. In the 1920s, it took 200 tons of water to make a ton of steel. That was just the process. In 1980, in the United States, it took 20 tons of water to make a ton of steel. That's a 90% reduction. Now, that happened not because we were trying to save water, but we were trying to save our steel industry. And the steel industry was trying to figure out how to become more efficient. And one way was to reduce its wastewater discharge. They were also trying to meet the Clean Water Act standards. The best steel plants today in the world use 3 or 4 tons of water to make a ton of steel. That's almost another 90% reduction. It used to take 30 gallons of water to make a square inch of semiconductors. Now it takes, in the best semiconductor plants, 3 or 4 gallons of water to make a square inch of semiconductors. It used to take 6 gallons of water to make a gallon of milk in a milk processing plant, not counting the cow. Now it's down to 3 or 4 gallons of water per gallon of milk. We're becoming more efficient, and there's enormous potential to improve efficiency much farther. Fourth, water quality. We have to get much better at matching the quality of the water we have with the quality of the water we really need. This issue of wastewater is a good example of that. We don't really need to be collecting water, treating it to an incredibly high potable standard, and then using it to flush our toilets. We could flush our toilets with a different quality of water if we had the piping and distribution systems appropriate. We don't need to be using high quality potable water to water our golf courses. Let's match quality and demand much more effectively than we have. Part of the water quantity problem in many parts of the world is actually a water quality problem. China's growing water crisis is partly a result that northern China is relatively water short compared to southern China, but it's partly a result of the fact that they have grossly contaminated the water that they have, and they can't use much of it. So water quality is a key issue. In the United States, I would argue it's time in the 21st century to rewrite the Clean Water Act and the Safe Drinking Water Act, these foundational laws that protect our drinking water and our rivers and streams and lakes. They were designed for a different world than we live in the 21st century. Let's bring them up to date. Fifth, we need to price water properly. Water is a human right. I believe that very strongly. I wrote a paper about it a decade ago. But it's also an economic good, and figuring out how to balance the human right aspect of water and the economic aspects of water is a key issue. The truth is, most of us pay far too little for the water services that we get. Let's figure out how to price water fairly and equitably, and yet in a way that permits us to expand and sustain our water systems. Sixth, let's protect our ecosystems. Let's guarantee water for the natural environment in a way that satisfies human needs, but also protects human health by protecting ecosystem health. Finally, we need to expand our concepts of water management, and we need to rethink our water institutions. We have so much in the 20th century focused on centralized water institutions. And yet we live in a world in which decentralized systems may be very effective. We're very good at building big dams. We're very good at spending $1 billion on a water system. We're not good at spending $1,000 in a million places. And yet today, often the water solutions we need are $1,000 in a million places. That's the same $1 billion. But our big financial institutions don't know how to do that. And that means maybe we need new financial institutions to help us address water issues at the community level and at the watershed level. Let's involve the public in decision-making over water. Again, in the 20th century, most of our water decisions were made by engineers. And I have an engineering degree, and I appreciate that. But communities know what they want when it comes to water. And the most successful examples of sustainable water management are coming up from the community level nowadays. Let's acknowledge and deal with climate change. That's going to require better integration of institutions. Energy and water are closely connected. It takes a lot of energy to collect, treat, move, distribute water. It takes a lot of water to produce energy. And yet, our water planners are over here, and our energy planners are over here, and our land use planners are over there, and none of them talk to each other, and it leads to bad decisions. So our institutions and our management about water must be much broader in the next few decades. And we have to address growth in a comprehensive and responsible manner, something we're not doing. All of these approaches together, all of these pieces of the puzzle are the soft path for water, a path to a sustainable future. And the good news is that in every one of these examples, in rethinking supply and rethinking demand, and the smart use of economics, in new institutions, in ecosystem restoration, there are examples out there of people doing great things, of success stories. There are pieces of this puzzle out there, and if we learn from them, and if we put them together, and if we use them to teach, we will, I think, inevitably move to a sustainable planet for water. This is a remarkable time to be working in water. There are serious risks. We face serious risks. We face truly a water crisis that we have not yet resolved. But I also believe that real, effective, affordable, and attractive solutions are out there that can help us make the transition from where we are, not to where we can see that we're going, but to where we want to be. The challenge, I believe, is making sure that that transition is fast enough and in the right direction to avoid the painful problems that we will otherwise have to deal with. Thank you very much.